Okay, so now I'm going to go through and explain this. Homework number 1, problem 3. Problem, how the problem is defined is that we have 3 blocks, A, B, and C, that are kind of fitted in between block D, each having dimensions lowercase a, b, c, and d as it shows, and our information is defined right here. But as we go through the problem, we're going to determine what the mean gap, W bar, and its tolerance is. And in part 2, we're going to determine the smallest mean size of D that will ensure that W is always greater than or equal to 0.010 inches. So getting started, it's pretty straightforward with the initial part solving for the mean gap W bar. It's going to be equal to our average D minus our average A minus our average B and minus our average C. So when we go through this, it's actually going to end up being 8.025 minus 2.5 plus 2 plus 3.5, which ends up equaling 8. So when we go through and actually solve that out, we get 0.025, which is that solution right there. And for the second part, we're just going to add up all the tolerances so that when all of them are the smallest and all of them are the largest, what's going to be that tolerance. So in that case, we're going to end up having T of C is equal to A bar plus B bar plus C bar plus D bar. And when we add all of those up, we end up getting 0.002, 0.005, 0.005, and 0.01. So I mean, you can go ahead, bring those together, make it 0.01, 0.022. Is going to be our maximum and minimum tolerance from our mean gap. So that's how we ended up solving for that. Now going on to part 2, determine the smallest mean size of D that will ensure that W is always greater than or equal to 0.1. How we're going to end up solving that is we're going to set our W min is equal to 0.01. And what we do from here is we're going to say that our new W bar is going to be equal to 0.01 plus our T of C, or this value right here. So overall we're going to end up getting 0.032. And now we're just going to add up the mean values for blocks A, B, and C and add in this W bar to end up getting our final value. So we've already calculated that being 8, and we're going to add the 0.032 and end up getting 8.032 as our smallest mean size of D.